My name is Krajcsovits, Krajo for short, for obvious reasons. And I'm going to talk about a little bit about custom buckets, native histograms with custom buckets, because they came up in the Prometheus remote write 2.0. And I think not many people actually know what they are. And I submitted this talk like a couple of hours ago, so we'll see how it goes. This whole thing is work in progress, and I can't take full credit for it. Most of the ideas and the original native histograms come from Björn, as most of you know. And I will skip slides that are kind of obvious. You all know about how we store float series that represent counters or gauges. You all know about histograms, what histograms are. They are like a distribution of observed values, but not the values themselves. And most of you will know that the classic histograms are stored in multiple time series in Prometheus, or they used to be stored in multiple time series, where you had your sum, count, and you had your bucket time series, right? And these had many problems, and were many drawbacks in a lot of situations, and so Björn and Ganesh started the work, and eventually we had exponential native histograms. And I'm going to prefix it now with exponential native histograms for reasons that will become obvious later. So in the exponential native histograms, you get a single time series that represents your histogram. It's a new data type, and it, as the name suggests, it uses exponentially, like the bucket boundaries are calculated from an exponential function. So that's native histograms, exponential ones. And however, sometimes that's not the right fit for what you're trying to do. Sometimes the exponential scale itself doesn't fit your data. It gives you like the wrong representation. Sometimes you have code that's legacy, that you lost the compiler for or whatever, and you cannot change the instrumentation. Sometimes you would want the benefits of native histograms, like transactionality, like we saw in the Seznam's case. Or the sparse representation, but you don't actually need those exponential buckets. And also, another idea behind this custom bucket is to open up the implementation of native histograms for more exotic bucket types or representations. So what are custom bucket native histograms? Basically, again, we are storing the data of the histogram in a single time series, but instead of exponentially calculated buckets, we also store what are the bucket boundaries. So basically, we are putting your classic histogram at scrape time into a native histogram without losing any information, because we keep the bucket boundaries. So this is not an approximation. This is like an exact representation of the classic histogram. And since this is on scrape time, you don't have to touch your application. And the support for this is, like I said, is work in progress. Some of it is already in remote write 2. Some of it is already committed in Prometheus, but nothing is turned on yet. And you can read more about it in the proposals repo. Just to call back again to that in earlier talks. There's a meta issue that you can check out, like what's the progress, where you can help. The huge caveat that I need to make here is that these are native histograms now, so your queries will change. You will not be able to use the old queries where the name of the time series ends in count, in sum, in bucket. These are native histograms, so you need to do the new queries. We did discuss in the proposal whether to add like an emulation layer or something like that to not have to do this, but that seems like a lot of work and a lot of code to maintain over time, which we would throw out. And to be honest, there are some ideas already to eventually maybe deprecate the classic histograms and just switch over to native histograms with exponential and custom buckets and other bucket types. Thank you for your attention.